Welcome to Civil Engineering Branch, ISRO Assistant Engineers under the branch of Civil Engineering Aspirants. Welcome to ACE online platform. In this video, we are going to present the necessary basic concepts you must practice and learn along with some very typical models that are likely to come in ISRO examination. Compared to the GATE and other competitive examinations, ISRO will have slightly lesser standard of the paper I am telling you. They will be covering all the important topics, but the problems and question standards will be slightly lesser than the standard of the questions of the GATE and engineering services. In other way, it is an added advantage for the real aspirants. Even if you miss GATE, you may get a chance to enter into ISRO. Then your life will be fantastic. Let us see first, we will be covering the water resources engineering. We know there are two parts. First part is irrigation engineering, second part is engineering hydrology. First we deal with irrigation engineering. There is no need of covering all the fundamental definitions and other things. Most important points only. The first point, you must give the concentration for methods of irrigation. Methods of irrigation is one most important area. When do you go for surface irrigation? When do you go for subsurface irrigation? When do you go for sprinkler irrigation? All the three types of irrigations, they will ask in which of the following situations sprinkler irrigation is permitted. When the groundwater table is too low, when the area is suffering from rainfalls, insufficient rainfalls, when the area is having lots of ups and downs, when the soil in the fields are having less porosity and more permeability, there is no other option but going for sprinkler irrigation. So methods of irrigation is one general area where the question will be given. The second one is, what is the relation between soil, water and plant? How much water shall we deliver? Where that water will get stored? Suppose if we have a soil mass, in the soil mass we got three waters. One water is excess water. That water is called gravitational water. Gravitational water. Gravitational water is the undesirable water. If we supply the water to the field beyond field capacity, it is not possible for the crop to get irrigated properly. Such excess water is called gravitational water. Most useful water is called capillary water. Capillary water is the water that can be taken by the plant for its growth, and inextractable water is hygroscopic water. Inextractable water is called hygroscopic water. So we should be thorough with all these concepts. Then the 6 moisture contents: saturation capacity, field capacity, optimum moisture content, temporary wilting point, permanent wilting point and ultimate wilting point. In what zone, which one is to be taken, that you must take care of. What is capillary water? Capillary water is between field capacity and permanent wilting point. It is the water that can be taken by the plant even against gravity. Against gravity, the water taken is capillary water. The water we cannot take and still retains in the soil mass, cannot be taken by the capillary action of the roots or soil molecules, that is called hygroscopic water. We should know the basic water requirements of the crop. Water requirements of the crop is the one important area where generally questions are asked on duty delta relation, delta is equal to 8.64 B by D. Delta is the total depth of the water. Duty is area divided by discharge. Commonly asked definition. What is the definition for duty? Area irrigated divided by discharge delivered. Area irrigated by discharge delivered. Base bid is also one important definition. Right from the first watering to make the land ready for cultivation up to last watering is the watering given to the crop before harvesting. Last watering, first watering to last watering time interval is called base period. Such fundamental definitions are very, very important. You must be thorough about the delta value. Delta is the total depth of the water. Then frequency formula, dW divided by Cu. Cu is called consumptive use. Consumptive use is nothing but daily demand of the water. Consumptive use is also called as daily demand of the water. It is also one very useful definition. I need not say dW. dW is S into D into FC minus OMC. It is the depth of each watering. Every time how much water farmer will be supplying to the field in order to get the crop properly irrigated throughout the 10-15 days. That gap is called frequency of irrigation. Frequency of irrigation is also one important one. Then if you observe, the next area very commonly asked is, they may ask regarding the quality of irrigation, water application efficiency. Water application efficiency is equal to Q plant divided by Q field. How much water is delivered to the plant, how much water is supplied to the field. Water conveyance efficiency, Q field by Q canal. How much water is taken from the reservoir, that is Q canal. How much water is given to the field, that is after the canal losses. Overall efficiency is equal to application efficiency into conveyance efficiency. This formula is one important area. A question may be given on irrigation requirement. Friends, we know what is irrigation requirement. Irrigation requirement is the daily water demand of the water. Daily water demand at a given location for a crop. For a given crop, the daily water demand at a given location, that is in the units of mm per day. At the plant CIR, at the field FIR, at the canal system GIR. These three are most important relations. Most important relations you can remember. And then you must know what are the duties at various points, also important. Duty at various locations. At various locations you must and should remember. That is gross quantity, literal quantity, net quantity at a major canal, net quantity at minor canal, and outlet factor. One most important definition, duty at the entry of the field, duty at the entry of the field channel, duty at the exit of the field channel or entry of the field, that is called outlet factor. Out of the 5 duty values, outlet factor is the most important one. Then afterwards, when you see the design of the types of the canals, you can see, when you see about the canals, what are the types of the canals? Lined canal, unlined canal. We'll be calculating the benefit cost ratio. If the benefit cost ratio more than 1, we go for lined canal. If the benefit cost ratio less than or equal to 1, we keep the canal as unlined canal. For the water to supply to the field, either we will be taking the help of lined canal or we will be taking the help of unlined canal. Generally, main canal, branch canal or lined canals, major distributary, minor distributary and field channel are unlined canals. So for lined canals, if the discharge is less than or equal to 75 cubic, we get a triangular lined canal. Triangular lined canal we get. For that area formula, y square into theta plus cot theta. Wetted perimeter formula 2y into theta plus cot theta. Formulas may be asked. In one examination it is asked also. If the discharge is more than 75 meter cube per second, for that lined canal we take the trapezoidal cross section. For a trapezoidal cross section, we take area is equal to by plus y square into theta plus cot theta. Wetted perimeter b plus 2y into theta plus cot theta. These formulas for lined canals, these 4 formulas are sufficient. You must remember R value y by 2 for a triangular lined canal which is not valid for a trapezoidal lined canal. This is one important relation you should remember. One more also, when you differentiate the formula of area with y, you are going to get P for both triangular and also trapezoidal lined canals. Triangular and trapezoidal lined canals, we are able to get these conditions satisfied. That condition is valid only for triangular lined canal. And then other types of canals you must remember. When do you say canal in cutting, canal in filling, and then balanced canal? When the quantity of soil required for cutting is equal to quantity of soil required for banking, then that is called balanced section. So like that we have the important definitions. How do you classify the canals? Based on the alignment. Based on the alignment we got ridge canal. It is also one important one. Based on the alignment of the canal you should practice well. Unlined canals is also one important area. One is the ridge canal, second one is the contour canal. Third one is the side slope canal. These 3 canals are important. And then other canal definitions you know pretty well. You must remember these points. In the design of unlined canals in alluvial soils, because alluvial soils are more subjected to silting and scouring, so you should take maximum precaution in the design of those canals. We got Kennedy's theory. Kennedy has developed the critical velocity concept, where the quantity of silt entering is equal to quantity of silt leaving the cross section. He has given the formula for V0, 0.55 m d power 0.64 is the single formula. Using this formula we are able to get B and D. S0 value cannot be determined by Kennedy's theory. If you are asked what is the most important disadvantage, what is the most important drawback of Kennedy's theory while designing the unlined canals in alluvial soils, our answer, inability to calculate the bed slope. Inability to calculate the bed slope is the one major drawback. Then regarding after the Kennedy's theory, Lacey was in between we got the graphical procedure. That's not necessary. If somebody asked on which theory we are designing the unlined canals, now answer is Lacey's theory. For unlined canals in alluvial soils, you may ask what are the assumptions valid. Discharge constant. Wherever coherent is there, incoherent alluvium soil must exist everywhere in all directions, either at the incoherent alluvium soil is existing either at the bed or canal beds or side slopes. Then average diameter of the silt is constant. Quantity of silt per unit discharge, silt charge is also constant. It is called silt grade. Silt grade and silt charge both are constants. Under these assumptions, we got 6 formulas for the design of unlined canals. The empirical formulas given by Lacey, let us see. First formula, V is equal to QF square by 140 whole power 1 by 6. Second formula, Q will be given to you as the input parameter, F is not given. F is the silt friction factor, it is given by average diameter, I told you, 1.76 square root of D50. D50 must be taken in millimeters. Third formula, V is equal to root of 2 by 5 FR. Fourth formula, wetted perimeter is equal to 4.75 root Q. Wetted perimeter discharge relation, once he has given velocity of the flow in a canal, unlined canal given by Lacey's theory, depends only on discharge. Answer, that is statement is incorrect, because it depends not only on discharge but also the average size of the silt particle available along with the canal water available at the bed or available on the side slopes. At all three locations, with the water, at the canal bed, on the side slopes, same size of the silt must exist. S0 is equal to F to the power of 5 by 3 divided by 3360 Q power 1 by 6. These 5 formulas are most important, and we can get all the parameters calculatable. Other formulas are there, like for example, Lacey's cover depth is equal to, in terms of unit discharge, Q square by F whole power 1 by 3. In terms of total discharge, 0.47 Q by F whole power 1 by 3. In terms of discharge per intensity, discharge per meter width, small q, Q square by F whole power 1 by 3. And proportionate factor is 1.35. Suppose if the total discharge is given, without giving the canal bed width, if the total discharge is given, your formula will get modified. Lacey's Resine's cover depth from the bed of top edge of the canal up to what depth of the possibility of covering will take place. That is 0.47 Q by F whole power 1 by 3. These are the formulas you should remember regarding Lacey's. Lacey's formulas got only one drawback. Everywhere F will be available. So if you take proper precaution for F, design details and design outputs given by Lacey's theory are very, very, very accurate. And then when we see the canal regulation works, as most of you know, one of the common area where the questions are asked, canal regulation works. In this, they may ask about canal falls, they may ask about canal regulators. Most important is the cross drainage works. Cross drainage work, they will give the details of the canal and drain. Details of the canal and drain they may give. One canal is going like this, one drain is like this. Here canal discharge 200, drain discharge 20. What type of cross drainage work you are going to provide? So because you are permitting drainage water to travel at higher elevation, it must be a type 2 cross drainage work. Type 2 cross drainage work we are going to provide. If there is a negative pressure flow condition that is existing, then that is called canal siphon. Canal siphon, otherwise it is called super passage. Suppose on the other way, if a canal water is 20, drainage water is 180, something like that. Drainage water is going on the ground and canal water go to higher elevation and come back. That is type 1 cross drainage work. In that, without negative pressure creation, aqueduct, if maximum flood level of the drain is touching, the bed of the canal traveling at higher elevation, some part of the flow, the drain water will have flow under negative pressure condition. That is called nothing but siphon aqueduct. These 2 points you must be careful. In siphon aqueduct, when do you have the pressure maximum? You must be careful about this. Then they will ask canal modules. What is the difference between canal rigid module and semi-rigid module? What type of modules are commonly asked? Rigid module, that is GIPS rigid module. It is one of the PYQs of our ISRO Civil Engineering Assistant Engineers Examination. So, such details you must be practicing. Then, canal escapes also important. In order to dispose of surplus water, we use flush escape. And to get disposal of all the surplus silt, that is tail escape. Flush escape and tail escapes are the two canal escapes we are going to provide. So, these are about the canal regulation works you have to understand. There may be sometimes some questions may be asked on river training works. River training works questions may be given. Then you have to observe what are the different river training works. Marginal embankments, you must know where they are provided, what is the use. Marginal embankments, guide banks, then supporting banks, then spurs, then groins, then artificial trenches. All the six river training works are important. They may ask a question on Himalayan rivers and non-Himalayan rivers. They may ask a question, what is the major difference between spurs and groins? Spurs and groins they may ask. So these are one important area. Next, we should give top importance to diversion headworks also. Examples of diversion headworks are weirs and barrages. If you use a cross section, if you give weightage for the fixed head, that is called weir section. If you give the weightage for this gate or shutter, if it is height H2, this height H1, if H1 is more than H2, that is called weir section. If H1 is less than or equal to H2, that is called barrage section. Compared to weir, barrage is most preferable. If somebody asks you between weir and barrage, which one is more preferable? Because of possibility of getting higher efflux, maintaining higher efflux, and possibility of getting the good highway traffic also permissible. Always a barrage is preferable compared to the weir section. What are the possible failures of the weirs? Possible failure of weirs. About the 5 possible failures you must understand. First failure is sloughing failure. Second failure is the rupture of the floor because of the improper or inferior quality of concrete, rupture of the floor. The third one is overflow over the crest. Fourth one is failure due to uplift pressure. When the downward weight is lesser and uplift pressure is more, the dam will get ruptured, the weir section. And fifth one is the most important one, piping failure. About piping failure, please learn a lot. There are 3 theories available: Blaise theory, Lane's theory, and Kosla's theory. Blaise and Lane's are simply giving Blaise theory. Blaise theory is called Blaise creep theory. Lane's theory is called Lane's weighted creep theory. While calculating the creep length to make the flow against piping, to get the weirs protected from piping failure, Blaise theory is taking the creep length calculation 1 horizontal to 1 vertical. More scientifically, Lane is considering 1/3 horizontal to 1 vertical. Lane has taken more scientific. Some question may be given out of Blaise and Lane, which theory is more scientific? 95% both are same. What is the major drawback of Blaise theory or major advantage of Lane's theory? Your answer must be Lane's is more scientific because in real, K horizontal is more than K vertical. As K horizontal is greater than K vertical, less weightage is given for horizontal creep. Less weightage for horizontal creep. That's what the question may be given like this. Then about cost loss theory. The third one is the cost loss theory. The theory is called cost loss exit gradient theory. Most important points cost law has given. There is no need of upstream pile. The line diagram given by cost law is this. It is B, it is D. The head of the water meant for diversion is H. If you are asked what are the most important input parameters for the design of the weir section, your answer is H, B, D. Head of the water meant for diversion in the river. B is the width of the impervious horizontal floor. D is the depth of the downstream pile or downstream cutoff. If you remember these three, you have to calculate alpha B by D. Then you have to calculate lambda 1 plus root of 1 plus alpha square by 2. Then exit gradient is calculated H by D 1 divided by pi root lambda. If somebody asks you the difference of the hydraulic gradient between input and output, inlet and outlet of the weir section, that is called exit gradient GE. Input section at the river, outlet section on the downstream side of the weir. What is the hydraulic gradient? Head of the water lost per unit length of the creep. Head of the water lost per unit length of the creep. That's the general formula for hydraulic gradient. It is now converted into exit gradient by this formula. What factors will control the exit gradient of a weir structure? H, D and lambda. Lambda depends on alpha. Alpha depends on B and D. So if GE is controlled by which of the following combinations? Answer H, D, lambda controlled by alpha controlled by B and D. D already written. So the three input parameters required H, D and B. These are one important area. And then about the diversion adverbs that you can take up. When you take the gravity dams and spillways, in what situation what dam is constructed? What is the general height we should observe? Height of the dam, type of the dam, suitability of the dam, suitability, all these factors we must be taken care. The three profiles of the gravity dam. What do you mean by common profile? What do you mean by practical profile? What is meant by elementary profile? The three profiles we are having: common profile, practical profile, elementary profile. These three profiles we have got. When do you say high dam? When do you say gravity dam as a high dam? When the limiting height is greater than, when the height of the dam is greater than when H is greater than HL, it is a high dam. When H is less than or equal to HL, that is a low dam. HL is called limiting height. Limiting height depends on the metal of the concrete we are using. F divided by gamma W into S minus Cu plus 1. F is the permissible compressive strength of the concrete used. Gamma W is the specific weight of water. S is the specific gravity of water, concrete. Cu value is the uplift pressure coefficient. If rock is available, Cu will become 0. For Cu value for rock is 0. Other than rock, Cu value for all other things 1. For non-rock materials. If this formula is the limiting height of the dam, if H is more than HL, high dam. If it is high dam, all the forces must be considered. All the forces means both major forces and minor forces must be considered. what are the failures of the dam is important. Failure due to sliding, SFF, FSS. FSS is given by mu sigma V divided by sigma H. SFF is given by mu sigma V plus BQ divided by sigma H. This must be more than 1. This must be more than 2. Failure due to overturning moment. Overturning moment. When the sum of the clockwise moments is lesser than sum of the anti-clockwise moments causing stability, the dam will be safe against overturning. So factor of safety against overturning is equal to algebraic sum of the moments resisting divided by algebraic sum of the moments overturning. If this value is more than 1, safe, is more than 1.5, best. Then as given the failure due to compression, maximum compressive stress must and should be less than F, permissible compressive strength of the concrete mix used. To be more specific, sigma max Pn secant square phi minus P tan square phi. This value must be less than Fc. Even it is less than Fc, F is nothing but permissible compressive strength of the concrete. Then what is the formula for tension failure? To avoid tension failure, E must be less than or equal to B by 6. At any cost, line of action of the resultant of all the forces should not fall outside the middle one-third of the base. If the line of action of the resultant of all the forces fall within the middle one-third, safe. Otherwise, the dam may fail due to tension. To check whether the dam will fail by tension or not, you have to see at heel. To check whether the dam is going to fail in compression or not, you have to see at toe. Remember these points. Then regarding spillways, the overflow section of the dam is called spillway. We got two spillways. One is Vogie spillway. When the river length is when the river width is around 1 kilometer, we can go for Vogie spillway. If the river is between the two mountains having the width of around 100-150 meters, there is no other option but providing siphon spillway. Most prominently, the two spillways we provide with a sufficient width of the river, Vogie spillway, with a negligible small width of the river around 100 meters. Our width of the spillway will be around 10 to 15 meters. That is called siphon spillway. Vogie spillway, siphon spillway. These points are important regarding irrigation engineering. Let us see what are some questions given in the papers. This is hydrology questions have come. Don't worry, let us see the synopsis of the hydrology also. A convective precipitation, it results from lifting of air masses converging into low pressure area, that is going to be cyclonic precipitation. And of course, just wait for 1 minute, we will be taking the hydrology theory also. Let us consider some important questions given in the previous years of ISRO papers, and then we will see some expected questions also. The quantity of water retained by the subsoil against gravity is dash. Obtainable water is specific yield. Obtainable water is specific yield. So the answer for that is the quantity of water retained by the subsoil against gravity is known as specific retention. Specific quantity of water obtainable by subsoil is yield or specific yield. Yield is total water. Specific yield plus specific retention is equal porosity. N is equal to SY plus SR is the formula we get. The ratio between the area of the crop irrigated and the quantity of water, I told you, duty, delta and base period, all the three are important derivations. Here has given the definition of duty: area irrigated divided by discharge delivered. Area irrigated divided by discharge delivered. So that is called duty. Duty is the correct answer for this question. The whole period of cultivation from the time when irrigation water is first applied for the preparation of the ground at the time of sowing until the last watering before harvesting is called, from the first watering to the last watering, I told you just now, base period. Core period is the second watering given to the field or first watering given to the crop when the crop is few centimeter. Core watering is also one important definition they will ask. For the given question, the answer is base period. Base period is the right answer. If the crop rice requires about 10 centimeter depth of the water at an average interval of about 10 days and the crop period of the rice is 110 days. So in 110 days we will give 11 times, 11 into 10, 110 centimeters. 110 days divided by 10 days per each watering. So we can calculate that is 11 waterings. 11 waterings every time how much? 10 centimeters. So total water depth delta is equal number of waterings into depth of each watering. Answer for the problem is 110 centimeters is the right answer. 110 centimeters is the right answer. Aquiclude is dash is actually question from hydrology. Aquiclude, it will store the water, it will not give the water. A solid impermeable layer underlying or overlying an aquifer, artesian aquifer, it is a non-artesian aquifer. Non-artesian aquifer. The vertical wells provided along the banks of the river to draw groundwater in dry season is called infiltration wells. And iso height is the line joining the points of dash. Iso height equal depth of rainfall. Because it is a common subject of engineering, hydrology and irrigation engineering, will be having the questions entrapped in both the areas. An artesian spring is formed when an aquiclude gets exposed in a valley against a vertical cut due to the presence of the continuous fault in a rock. When the porous strata gets confined between the two impervious strata, C is the right answer. In gravity dams generally, a question may be given. Upstream side we got 90 meter, downstream side we got 9 meter. What is the resultant water pressure can be asked. as a common standard value, you can take gamma water as 10 kilonewton per meter cube. You can solve the problem gamma by 2 multiply with h1 square minus h2 square. Such questions may be asked. It is 10 by 2 multiply with 90 square minus 9 square. It is 8100 minus 81, 80190 by 2. 40,095 kilonewton is the answer. 40,095 kilonewton. Such question may be asked. The question may be given on elementary profile also. It is 25 meters. Coefficient of friction is 0.6. S concrete is 2.5. You may ask what is the height of the dam section. I can get the formula B minimum is equal to H divided by mu into S minus C. B minimum is equal to H divided by root of S minus C. H is the height of the dam. B is given 25. Mu is given 0.6. S is given 2.5. He says full uplift C value 1. If he says full uplift C value 1, if he says no uplift C value 0, you can calculate H1, H2. Whichever is the lesser height, that will be provided. More than that height should not be provided. Then we can see in the spillways what type of questions are asked. In Vogie spillway, Q is proportional to dash. Q is equal to CLEHE to the power of 3 by 2. So Q will be proportional to H power 3 by 2 is the one common question asked. If it is the siphon spillway works on the principle of dash. Q is equal to CD into A into root of 2GH is the formula for discharge, surplus discharge coming from the reservoir over the dam section at the location of the siphon spillway. How much excess surplus water will go? You can calculate very easily by this formula. So Q is proportional to root H. Which of the following statements are correct? It may be given. For Vogie spillway, Q is proportional to H power 3 by 2. For siphon spillway, Q is proportional to H power 1 by 2. So you may ask on the percentage errors, you may ask on the graphs, you may ask the questions on log Q versus log H. Also, there is a possibility of asking questions on in the spillway. Supported with that, we are going to see based on the downstream side of the spillway, we have to provide the protection works. 5 types of protection works are needed, but generally in the ISRO, so far the questions are not given in that. Type 1, type 2, type 3, type 4. When there are 2 lines available based on the hydraulic jump. One is jump height curve JHC, and the second one is the actual length of the downstream side depth of the water flow on the siphon spillway or on the Vogie spillway. Based on that, when they are coinciding, is the best one. There is no need of any protection work. So anyway, that is not that much important, that area. Only concentrate on these areas. When the water level on the downstream side of the weir is above the top surface of the weir, when the water level on the downstream side of the weir is above, then it is called as submerged weir. Submerged weir is the answer for that. Submerged weir. The cover depth of a river during the flood may be calculated from the Lacey's equation. It is I have given to you. Lacy's cover depth value, if it is per unit discharge 1.35 Q square by F whole power 1 by 3. If it is the total discharge in terms of total discharge, Q by F whole power 1 by 3. So this is the correct answer for this. For determining the velocity of the flow of underground water, the most commonly used empirical formula, velocity of the flow of underground water, Darcy's formula, flow through any porous medium, V is equal to Ki is the formula we use, V is equal to Ki. The normal cover depth, D below the design flood level of the river may be calculated from the Lacy's equation. Once again, D formula is correct. C value 0.47. So Lacy's regime's cover depth is equal 0.47 capital Q by small f whole power 1 by 3. And then a fall in the canal bed is generally provided when ground design bed slope exceeds the ground slope. Ground slope exceeds the design bed slope. Design bed slope is exceeding when the ground slope exceeds the design bed slope. Design bed slope 1 in 10,000, 1 in 8,000. Existing ground slope 1 in 1,000. Here it is steeper. Required bed slope is flatter. I should make the water to go to lower elevation. How to bring the water in a canal? How to bring the water from higher elevation to lower elevation? By permitting the water to flow through canal fall. So option A is the right option. Irrigation canals are generally aligned along, I told you, along the watershed line, also called ridge line, also called gravity line, from higher elevation to lower elevation. So ridge line or watershed line is the correct answer. The difference in level between the top of the bank and supply level in a canal, top of the bank and supply level of the canal is called as freeboard. Freeboard is the freeboard. Freeboard is the definition between top of the bank. If we have this is the free surface of the water, it is the top of the bank. So this is called as freeboard. Freeboard is the answer for that. Conceptually, very fundamental. Waterlogging and quality of irrigation water is not there for our ISRO engineering examination. So I wish you good luck in irrigation engineering in this regard. Good luck to all of you. Friends, hydrology will be, engineering hydrology will be covered on some other program. Please follow our AS online programs for better videos. Good luck to you all. మనం స్లోగా అని చెప్పి ఫాస్ట్గా చెప్పాను.